So we'll okay, welcome to lecture 34 on thermodynamics of materials. So we will continue with the efficiency of cyclic engine. So just quickly. This figure will be helpful for reference. This is PV diagram, and this is, as you know, one high temperature reservoir, we say, source, okay, source, okay, source, high temperature, source temperature T1, and Q1 corresponding heat involved at this. Q1 is actually, Q1 is W1 is RT1 ln V2 by V1, and this side is T2 sink, low temperature, or T1 greater than T2. So what is the efficiency of this cycle? Efficiency generally any cycle, any cycle is as I give you Q1 plus Q2 by T1. Remember, Q1 is positive, heat absorbed by the system. You can check there Q1. Oh, sorry, you note this here, it is also Q2. Heat absorbed by the system must be positive, work done by the system. They are equal. Also thermal process. So system n moles ideal gas, n moles ideal gas, it is. So this is generally true for any cycle. For any cycle, reversible or irreversible. Come in. Reversible or irreversible. Is this is T1 minus T2 by T1 for reversible cycle. For reversible cycle, this is general. Q1 is positive and Q2 must be negative. Okay, compression, it rejected. Work done on system, it rejected. Okay, compression. Okay. Good, very good. This I discussed last year. Okay, very good. Then I'll consider this. Okay, now let us rename T1. Since it's high temperature, I call it TH. You don't mind. H for high temperature. T2 and T2 is TL, low temperature. And another thing important here, Q1 is likewise the heat absorbed by the system. System is engine, cyclic engine. Okay, is what Q1 is, is positive. Is positive. So it is, remember Q1 is positive, is QH. 1H, 2L. Q2 is incidentally, Q2 is, since it is negative, but I want to make it positive. So what I do? Q2 is minus QL. So Q2 is right, Q2 is, heat reject is originally negative. So QL is positive. I wanted to deal with positive, all positives. Okay. Accordingly, sign will be changed. Okay, positive. So we say so much heat is Q1, Q2 is say minus 40 joule. Means 40 joule of heat is rejected by the system during the compression to the surrounding. to the thermostat, namely T2. Now when I say it is QL, then Q2 is 40 is rejected, its value is minus 40. That's why rejected minus 40. But when it is QL, we say it is 40 joule rejected. So what do we say here? Minus 40 is the heat interaction. Here I will say when consider plus 40. 40, okay, both of them plus 40. But then it will be properly changed. How do we change this? So eta cycle with this convention. So eta cycle under this convention is what? Tell me here, follow. Q1 has been QH and Q2 is minus QL. So this we will use for convenience, nothing. Very easy, very easy. 40 minus. So since I have made it minus QL, so it is now minus. So the change, see the change, by QH. Or is what? Is for any cycle, again write for any cycle, and this is TH minus TL by TH for reversible cycle. Again I tell what is the efficiency. Remember, you have no difficulty understanding. Tell me the ratio. Heat admitted into the system at high temperature. Ratio of what? Heat admitted? No, the work performed by the engine over the cycle. System is the engine. But the engine over the cycle divided by, I gave you this thing last day, divided by heat admitted at high temperature. So clearly you see, that means which is greater? Numerator or denominator? See? So theta is what? Nickel. Work done over the cycle. Work done by the cyclic engine. Work done by the engine over the cycle. And this is heat admitted into the system at high temperature. That is T1, numerical, that high temperature is T1 here, okay? So this is W cycle. So what is your feeling? This should be less than 1. Because this was not totally utilized. Work done is less than this. See, if it was this, a full, why it is less than this? Because some has been rejected. The heat that was then was not fully utilized and it was rejected to the surrounding in a subsequent step, subsequent action. And so it is less than this. And follow the number of ways. And this is the heat input. So it should be less than 1. And you see here also, you are very easy. Follow, either suppose here it is less than 1. T1 minus T2 by T1 is less than 1. And here also, T1, you can get a better here. See, this minus this, and this is all this. So this is also less than, clearly see less than 1. So it makes sense. And again, another thing I ask you, suppose how you show this? What is the work done? Figure, graphically. What is this? Area enclosed, cycle enclosed. So this is the, this is the numerator. And what is the denominator? Area under the curve, also some high temperature, also some area under that will be obviously greater than this. This can be shown. So number of ways you understand efficiency runs less than 100%, less than 100%. And when it can be 100%, we will discuss that. Okay. So these are the things that we already we discussed this. Now next take up. What is this? Now I give a statement. Make one statement. This is second law statement. A second law statement. Alright, second law S. In the form of, in terms of efficiency of engine. This is efficiency of cyclic engine. What is that statement? I will write this, but I may forget one thing very important thing. Write all the top, recall. Yes, what is this? I will write at the bottom. What is? Note, recall, in case DS universe is greater than 0, irreversible, spontaneous, and is 0, reversible, equilibrium, and less than 0, impossible, impossibility. This is the second law, universal statement, second law statement. The second law statement. The second law, basic statement or versus the second law. Okay. General statement or universal statement. Universal, I am writing universal statement. But there are other statements which should not contradict this. This you should note. The primary statement, most important, main statement. Okay. This is the okay. So this is the second law. But here we are saying this. What is the statement? This in short. Okay. Okay. So in short, I am writing reversible cycle efficiency is greater than irreversible cycle. This is the statement. This is the statement. What does it mean? In the form that is reverse, it is impossible. The language will be, it is impossible. Always speaking, number of times I am coming, it is impossible. So it is impossible to have a cyclic engine, cyclic engine to have a cycle with efficiency greater than or equal to corresponding to the corresponding reversible cycle efficiency. Note both reversible and irreversible cycle are considered to work between the same temperatures of source, both same temperatures of source and same temperature of source, and same temperature of sink. So it's a little bit lengthy. So given that same temperature of source and sink, reversible efficiencies, reversible cyclic engine efficiency is greater than irreversible cyclic efficiency, or opposite, irreversible cycle efficiency can ever exceed reversible. Means this is the maximum. Is coming from accuracy work done in a diabatic reversible isothermal reversible process maximum work is coming down to this. This is this. Now given this, so I'll show you how this is. We'll actually try to establish this with the help of this. Okay. So this thing. Let us consider three cycles as if three gentlemen, three contenders. Okay. Let us consider three cycles. Next, illustrate of this statement. Follow this. Let us consider three cycles, each operating between the source temperature, same source temperature, namely 500 Kelvin. You may note this. This is boiler temperature, superheated steam. Typically, boiler temperature, which is superheated steam. and same temperature, same sink temperature. What is this? 300, the ambient temperature, atmosphere, outside temperature, ambient, or say atmosphere, atmosphere, atmospheric temperature, which are the earth atmosphere. Okay? This is the given, two things. These are unchanged for this, but there are three data. Cycle 1 means three people came. There are three contenders. They are actually okay, submitting this data for acceptance of the cycle, for ratification of the cycle, for appreciation of the cycle, with some claims. They say, my engine takes this much heat and rejects this much. Likewise, other two. So what is common? I consider each case I consider QH, cycle 1, QH in each case for the sake of calculations, common. Oh, QH I've written, don't mind this, QH, okay? So QH is what? I'm giving you 2000 joule. 2000 joule, here, right here, that means you write here also you write in short. TH is what? TH, tell me. TH is what? Tell me here. High temperature, 500 Kelvin, and TL, 300 Kelvin is given to you. Note this, you are giving so quickly. This is common, but this is also you'll see common. QH, QL it is saying. I'm writing here. QL is said 1200 joule. See, easy, appreciate. So what he says? So my engine takes 2000 joule at the source temperature, namely 500 Kelvin, and rejects only 1200 joule. He says rejects only 1200 joules, not more than that. Rejection is not more than that, 1200 joule at the sink temperature, namely 300 Kelvin. This is the first cycle, okay? First contender's cycle, okay? Cycle 2, second one says, well, this I have not changed for understanding this problem. Still 200. Yes, sir, given, it takes here again 2000, but converts, or rather, sorry, rejects, loses this. How much? It says, no, 1500 joules. It says 1500 joules. Cycle 3, again QH, say he has given this 2000 joule, and he kind of making an extravagant claim. Supposedly very actually important claim, okay? Supposedly. That important claim was saying, okay, this thing. What is this? He says, it is 900. What he says? That engine, sir, rejects only 900, not much. So these are the three things. Identify the cyclic engine. Identify each cycle whether reversible, right? Reversible or irreversible or impossible if it turns out to be so. Because some extravagant, he says, my engine very efficient, only 900 rejection. No, giving this only rejection, the third party. Second, say moderate, 1200, first one, and the second is very actually okay, ordinary, pretty ordinary, that 1500 too. Let us see which is which. Now can I remove this? Can I remove? Yes, I can, perhaps as a start. Cycle 1. Let us examine cycle 1. Please, first of all, before you start, let us find one thing. For the purpose of reference, you do not know which is reversible, which is not. For the purpose of reference, quickly, you find out it is reversible. If it is a reversible cycle, under the given condition, what it is? Reversible cycle. Reversible cyclic engine. Reversible cycle. A cycle means cyclic engine. Is what? You know what reversible, you have a simpler relationship. You can go by this Th minus TL by Th because these are fixed each case. And moreover, reversible cycle. So it is better you find out in the given Th minus TL by Th. What is this value? 1200. I am very sorry. 500 minus 300 by 500. 5 times 100 perhaps, no? Times 100 as percentage. What it is? 2 by 5 into 100, 40. So 40% efficiency is the reversible efficiency. And we wonder whether these efficiencies exceed this or stay less than this or equal to this. Then accordingly we identify if it is equal, etc., etc., reversible itself. Greater than, greater than we'll see, cannot exceed in the statement, impossible perhaps. And if less than, irreversible, sir. And we have the conditions here. In terms of entropy, this is efficiency, follow the discussion, okay? Follow my motive. Motive is, plan is what? This is one way, impossible, irreversible, reversible. Criterion, universal criterion. Here today, in terms of efficiency of engine, and they must actually, and that must comply with this. Okay, they must actually in accord. They must be. So this will verify. Then we will be satisfied. Start now. Cycle 1. Given this, if this for the purpose of reference means it can. We have got the idea. It cannot exceed 40%. The reversible one maximum. So start cycle 1. I am taking this place. Cycle 1. Cycle 1. Do what? Not start quickly. Any cycle. Go by QH minus. What is this? Efficiency is efficiency. Cycle 1. Cycle 1 I have written already. Cycle 1. Right. Cycle 1 is what? Right. QH. Tell me minus Q for Q actually have written this way. Na? Don't worry. Q is capital or small does not matter though. Is what? What is this? QH minus QL by QH. I see here. What is these values? 1200. Tell me. 1500, 20,000. 2000. QH is what? First cycle. 2000 minus how much direction? 1200 over 1200 times 100 perhaps in terms of efficiency. How much it is? I am very sorry. 2000. So 8 by 20 times 100 means 40. 40%. What is your comment? What is your comment then? Same as reversible. It is a reversible itself. It is a reversible cyclic engine itself. So it is 30. How can it be? 40. What are you doing? 8 by 20. 40%. So means the cycle is inference. The cycle 1 is a reversible cycle engine. The reversible cycle engine actually cycle. Over this part, not over. This part is reversible in interpret, but to be reversible, this is the criterion in terms of the second law, universal criterion ds or delta S for the ds here. I've said delta S maybe ds or ds or right here ds or delta S. Since actually I am considering delta. Quickly, these I'll show you here. I don't have much space. Then I will remove this. Okay. So it is all written there. Th etc. Th 500 etc. Can I remove the top? Okay. Right. Complete this. Cycle 1 is complete. So from the entropy point of view, from the now, from the entropy point of view, entropy means inverse entropy point of view, let us be satisfied or verify. What is that? Delta S system and delta S universe. ds universe means delta S universe. Delta S system one line, delta S surrounding another line equals to. Then we will sum delta S system one by one. From the delta S system is what? See, this everything is detailed cycle. What is delta S system? And these are the two terms. These two. information on cycle 1. What is the delta S system? Huh? Delta S? Irreversible by T. Irreversible by T, delta S system. But I know the answer because it is a cycle, sir. So delta S system 0. Okay? These are all cyclic engine. These are all cycle. 3 cycles. Cycle. Be clever, be smart, take advantage of properties, state properties. Delta surrounding. Surrounding was actually, what is this? Tell me, see the QH is 2000 is absorbed, surrounding loses the opposite sign. So minus 2000 source side, surrounding the source, it is losing, boiler is losing that heat. Minus 2000, minus sign, minus by what is the temperature? Boiler temperature is what? See, high 500. 500, right? Nicely. One side. Two sides there. This source and sink also. These are two parts, components of the surrounding. One is source side, sink side. Other thing may consider adiabatic means plus this side will be what? It is minus. This is rejected into the surrounding. So it gains. So plus, I write plus. That surrounding is okay. Plus. Okay. Good boy. Plus. Okay. Now plus. Give it plus. Plus. What I wrote? 1500. 1200 by over 300. So quickly. So minus 4 plus 4 is 0. Fantastic, sir. Should be as it should be. Reversible cycle efficiency. No, I'm sorry, 0. So not yet over is 0. Hence complete this. Hence delta S universe. I want to finish this here. Delta S universe is delta S system is what? 0 plus 0. 0 plus 0 is 0. As it should be. As it supported by the so hence supported by the second law criterion. So hence supported, hence right as too much. I cannot help. Okay. So hence supported. I removed this. This is no longer required. Right here. Hence supported by the original second law. Okay, this by the second law. Okay, by the universal second law. Okay, second law. Okay, in terms of entropy. Okay, so by the second law and supported by the second law. What's the second law? Is universal second law. Next, cycle 2. Next is cycle 2 start. Cycle 1 is over. Remove this. Next is cycle 2. Similarly, quickly. Cycle 2, just copy quickly. Eta cycle 2, quickly. Now, I go fast. Eta cycle 2. You will have the data. So first say QH minus QL, right? As you did QH minus QL over QH. What are the values? 2000 minus 1500 over 2000 times 100. What is this value? 40%. No, 5 by 20, 25%. Is correct. 2000, 1500. 2000 minus 1500 by 2000 is actually 5 by 20 means 1/4, 25%, which is less than 40%. So it is accept. What type of cyclic engine it is? Is it reversible? What it is? Irreversible, less than reversible. Any cycle. Reversible is unique. Reversible. Other than reversibles are any irreversible. Sorry, any other irreversible cycle. And still another is impossible cycle. That is there. So again, remember, in actually no. I'll take this up later. Good. Case two. And thermometer and entropy wise and verification entropy wise. Entropy wise, quickly tell me delta system wise again. Delta system how much? And delta surrounding, quickly. Delta system how much? Delta surrounding how much? This is your right. So what is called? So inference. Inference is what? Give the inference. It is an irreversible cycle. It is an irreversible cycle. This inference. Let's take up. Take up. Entropy wise. Entropy wise, 25%. Hence inference. It is an inference. Inference. It is an so cycle two. Cycle two. It is means cycle two. Cycle two. Then what is the in terms of entropy? Quickly. Entropy. Delta system and delta surrounding. Zero again cyclic, since cyclic like last time. And delta surrounding, quickly. Tell me two segments. Two segments. Minus 2000 by what temperature? Same temperature as before. Okay. 500. So thank you. 500 plus what is 1500 by 300. So minus 4 plus 5 is plus 1. Plus 1. So delta is, so I am removing. So delta is inverse. I remove this line. Hence delta is inverse. Oh sorry, delta is inverse over the cycle. Over the cycle. Inverse cycle. Okay, cycle. Let's right here. Delta system cycle. Why cycle? Right here. See, entropy is a state property. Right. Right here. Right here. Since entropy is a state function. State function. So cyclic value is cyclic. Change is 0. Delta is inverse. Is what? Delta system. Right. Delta system plus delta surrounding, which is nothing but 0 plus 1 is plus 1 is positive. Positive. Hence approved. Hence in agreement. Hence it supports. Hence same result. Okay, same result. Okay, same result. But means positive means what is it? Hence what is the comment? Positive means right, that delta is positive is what? Irreversible cycle. The same comment. So where? So I remove all these things. You don't need perhaps anymore. If necessary, I'll write once more. Positive, hence same result, same inference. Same inference. What is the inference? Right? It is a irreversible cycle. Cycle 2 is an irreversible cycle. Quickly, over. Okay? Yes. Irreversible process. Means here cycle. Last one, cycle 3. Acha. Cycle 1, cycle 2, cycle 3. Cycle, this is reference, so keep it here still in case cycle 3. Cycle 3, discuss it quickly. Tell me which way you proceed first. In eta, cycle 3, quickly, what is again QH, right? QH minus QL by QH. What is this? 2000 minus 900. Minus 900 over 2000 times 100. So it is 55%. 55% greater than 40%. So questionable, highly questionable, rather impossible. What is the comment? So that is eta cycle 3 as efficiency greater than reversible efficiency. Reversible cycle. What is the implication? If it ever happens, is only impossible. I said no, 3. One is less than 0, another is equal to 0, another is less than reversible, another is equals to reversible, and third is greater than. This so indicating, so implying impossible cycle. Implying impossible cycle, impractical, impossible cycle. Huh? So, okay, in terms of, so I remove this cycle 3 and then remove this. Huh? This is not needed, these are all removed, junk. Cycle 3 only standing here. In terms of entropy, continue here, continue from this point. In terms of entropy of universe, in terms of entropy, try to corroborate by this. What is delta system again? And delta is surrounding again. System is what? Again cyclic, all are cyclic. So 0, surrounding again 2 components. What are the components values here? 2000 still standing here. This is a minus of that. Minus 2000 by 500 plus 900, that is by 300. What it is? Minus 4 plus 3 is minus 1, negative. Negative, so negative. So delta S universe is delta S system, delta S surrounding. Over the cycle, understandable is minus 1 is negative, hence impossible from entropy point of view also, from this statement also. Hence impossible. So they are in complete accord, these two, hence impossible. So what I wanted to tell you, I gave you a new criterion, efficiency of cyclic engine, but these all must accord to the original criterion in terms of entropy of the universe. Okay, so this is okay, happen. But how to sketch this? A quick feeling of this. The first one is what? Say this reversible, being reversible. Suppose this. The second one who said giving the same amount of 2000 joule. It says it is 1500. Suppose it is 1200 joule. Q2 is 1200. Okay, first one. So 1500 means more rejection than this. What will be figure like? And that is figure like, what is this? More. To be more. This is 1200. Area under the curve is the work done and heat. Same isothermal. So this will be. Sorry. This will be this. So right, I will show you like this somewhere, so that it becomes 1500 area under the negative though. You can what to have consider minus is already given. So QL value, absolute value is greater, area under the curve. So this is for who wants cycle? Tell me 2. What is this? This is for cycle 1, reversible itself. Cycle 3 says what? Acha, take a look. Efficiency is reduced. Efficiency is what? How much? 40%. That was what? 25%. Do you see this? What is the efficiency? Remember, W cycle I wrote somewhere. Yeah. Numerator by denominator. This is a constant 2000. This is varying. From this with the dotted line, reduce area. Work done. Over the cycle is the area enclosed. The enclosed part is now reduced compared to reversible enclosed area, reversible cycle. So see clearly, see this is the figure, and this should be also in your idea that area under the curve, compression, etc. Heat rejection. So this is the one. Okay. So you see efficiency has been reduced. No surprise. How will you sketch the third one? Sketch the third one, which is how he says that rejection is less. I don't understand. This cycle 3 does not reject as much as reversible. So it's less than. To be area will be less. So this will be. This is cycle 3. What is the? He says area is enclosed is greater than reversible itself. Greater, which is impossible. So that's what the cycle is impossible. Okay, see, follow. Area is greater, you understood? Okay, so lower and area enclosed is greater. When it is receding downward means the enclosed area is actually widening. So widening more than and becomes greater than enclosed area greater than the reversible cycle. So efficiency is greater. than reversible, which is impossible. So this is cycle 3. Cycle 1, so it is what? Impossible. Impossible cycle. Impossible claim. Impossible proposition. Cycle 1 is reversible itself. Reversible cycle itself. This is what? Cycle 2 is natural. Or pretty ordinary, common reversible cycle. So this is our discussion. Okay, this part. So this is very good. Next I take up. This bit is here. Okay, this is all. Okay, over. PV diagram. So next is acha, by the way. Well, you should note this when actually note Carnot cycle is what? Note cycle, reversible cycle comprised of adiabatic and isothermal and adiabatic, isothermals and adiabatic, is known as also known as Carnot cycle. This point, okay. So what is Carnot cycle? Okay, three great men, great. Okay. What is it? The thermodynamicists. Okay, three great pioneers. What do they? Three great pioneers. What is the name? First name is Kelvin, Carnot, and this Clausius. These three were second law. Who developed the second law? Second law of thermodynamics. First law, I didn't forget to mention. First law, remember, it started. This is 1867. I can give you this. Clausius' final statement, 1867. I will give you. Today I will give you the statement, but 1867. It started. First law started 1790. Perhaps 1790. First law, just okay. You may note also. You may note alongside. First law was developed. The first law of thermodynamics was developed. First law of thermodynamics was developed by who are the pioneers? Developed. The name should be very important. We should be very respectful. So it is developed by three again. Blake, perhaps first one. Blake, then Rumford, Count Rumford, British. All this. Next is another great name, Joule, and maybe Kelvin also. I'm not sure. I'll tell you which Kelvin is actually. Okay, good. These are the things. Another thing I tell you, this cyclic in the quickly say, this is the high source temperature is what? Boiler. Source temperature, how this works? Boiler. How a locomotive works? It takes heat from the boiler. Superheated steam, temperature say 500 Kelvin. And then it actually enters into cylinder piston device, and executes the cycle and rejects this much heat to the atmosphere. Okay. Running 300 Kelvin say. So this is this. Now this you see how, okay, sir. So this heat that you get from, again, you sketch a cylinder piston arrangement as you are used to cylinder piston. Okay. So this is fitted with the wheel of the locomotive. Wheel of the locomotive, means train of the locomotive. Steam engine or diesel engine, steam engine, how it works. Boiler temperature, superheated steam, say 500 Kelvin, and atmosphere, and okay, ambient temperature outside actually, or atmosphere temperature is 300 Kelvin. 27 degrees centigrade. So it takes, okay, then it executes expansion, compression, all such things. So it expands, okay, when it, so you feed it with the help of a crank. This is, this is crank. Crank is fitted here actually, no? Crank is fitted in middle. Crank and shaft arrangement. Crank and shaft arrangement. This is the crank actually hooked with this wheel, and this is the shaft. This is shaft. This is a cylinder. Okay. So when it is actually expands, let me do this. So first let us do expansion. Okay. So when it expands, okay, let me draw this quickly. So don't mind. Okay. Oh, well, leave it there. Leave it there. Okay. So when it say suppose this, when it expansion, as it is hooked with this, then it is actually, when it expands, rotates it. It rotates it. So when this complete expansion, it rotates about say it is better actually. I should give the hand. It's better. Okay. Then this rotates half circle. Full expansion here, forward motion. In the cylinder converted into rotational motion on the wheel. Converted rotational motion on the wheel. And then when it returns, it is expansion, and you returns, is it? Expansion, this covers adiabatic expansion also, as if a little bit mixture, but we understand the expansion mode. This here expand, and this rotates with the help of crankshaft arrangement, rotates half only. Then when it returns, this is compression, means these two, this compression steps leads to pull it here. Then when it actually go back, then it returns here. So this and this is the compression returns here. Okay, this you can think. This one it pulls this way. That's it also pulls it other way, and that executes one cycle. And this is rotational motion on the wheel, and this wheel is actually, this locomotive stands on the wheel. So when it rotates, this causes actually longitudinal motion for the locomotive. Any cart, okay, this block cart also same. When it rotates, there is longitudinal motion, okay, forward direction. This is rotates. So this is how these things work. Not necessarily steam engine or diesel engine also, diesel engine. Same. Only the fuel is different. Steam engine, who is the fuel? Carbon, coal is burnt and steam is generated. And diesel is the fuel, burnt fuel actually, they produce it. You have to get a hot gas, high temperature, that is the source temperature. These are actually in general, that's why we discuss this. Next is, I consider another second law statement. What is the name of this? Kelvin-Planck. Planck. 2 minutes only. CK, Kelvin-Planck. Planck. Yes, sir. Planck statement. You know Max Planck? Statement spelling is okay. Kelvin is also, remember, I am just writing. Kelvin is Thomson. Who is Thomson? Thomson is Kelvin. Lord Kelvin, finally. He got the Lord title, okay, for his actual outstanding work, Lord Kelvin. This D.D. Kelvin. So Lord Kelvin is Thomson also, same person. Okay, but this statement is quickly, let me write the statement at least. Then I will take up. Oh, there is a lot of things to cover. Kelvin-Planck statement is what? It is impossible. Again, see, note the way it is. It is impossible. It is impossible by means of a cyclic engine. To take it from a hot reservoir. They say reservoir also, sourcing or a reservoir. cold reservoir, thermostat. From a hot reservoir, without, by means of cycling, to take heat from hot reservoir and convert it into work, and convert it into work without transferring spelling is okay, I guess, some heat to a cold reservoir. What is the essential things about this? Follow this. Transferring some heat quickly. So it's impossible. What is impossible? You take it. Hot reservoir. But it must reject some heat to a cold one. This is a cold reservoir. See, it must. If you argue that nothing is transferred, zero transfer, then what is the efficiency will be? It will be efficiency will be what? The full is converted 100%, and that is impossible. That is impossible. Follow. Hence, that is reversible by means of cycling, by means of reversible, right? Reversible. If it works for reversible, it will work for other also. Eta reversible cycle is what? 100%. If no transfer, is 100. Even it is there, it does not transfer. Argue. It is there, but it doesn't transfer, doesn't interact. Impossible. Has to reject. Has to reject. If it does not, then 100%, which is impossible. Quickly. So it is 100% impossible. 100% impossible. Quickly. Quickly. What is this? So how do you get this? See, eta is what? QH minus QL by QH. Quickly. What it says? What is QL? Is according to this, you make it 0, then it becomes into 100 is 100%, but this is not possible. So this is QL is 0, not QL is 0, not, that is the message, not possible, impossible. QL is 0 is impossible. We use technically the word impossible. QL is 0 refers to impossibility. See again, no heat without means without transferring some heat. Transferring no heat. Okay, so 0. So impossible. Quickly, again, always will be satisfied through this statement. And you are satisfied. These are the statement, Lord Kelvin's statement. Very good, sir. Is okay, sir. Also looks like 100, but why, sir? Satisfy this. Satisfy with this. 100% impossible. Why, sir? What's the harm? Remember, reversible. Follow what you studied a moment ago. Reversible cycle is more efficient. Let it be so, but it can be so efficient that its value is 100%. No, that is not possible. Greater. 99% is possible. 99% is possible. Reversible efficiency. Anything. 100% is forbidden. 0 now. Any value will do. Less than 100. It's okay. Quickly in terms of entropy, can remove this, start it, and that's it. 1 minute or 1 minute. Start from this. In terms of entropy. Until it is in terms of entropy, you are not satisfied. In terms of entropy, tell me, what is your rule? Delta is universe. I'll check, sir. Delta system and delta surrounding. I'll be very happy with you. Remove this, all remove. System quickly, delta surrounding. Tell me from apply your knowledge here. In this case, you suppose no heat is rejected. No heat is rejected. You try to find out if it's possible, or rather you want to establish that it is impossible, sir. It is impossible. It was written. It was impossible. Statement beginning. It is impossible to. That means you consider that no, sir, no heat is rejected. Then it will be, you have to show that it is impossible here. Impossible here. What is delta system? Quickly. Cyclic. You should be intent on looking at this. You want to take advantage by all means. So you are not exploiting the weakness of thermodynamics. I do it very well. I can very easily exploit. I am actually on the lookout for this. Oh, cyclic. One down. One down. This is down. Surrounding. Surrounding, tell me what happens. Tell me now. Surrounding, tell me. Follow this. It takes hit. So again, according to before, takes hit means minus. Minus to negative. First part is minus. Minus, negative. For that part is negative. And right hand side is second part. No hidden induction, 0. Okay, this is source side. Okay, source side, sink side. You already done negative, 0. What is this? Negative. What is delta's universe? Tell me. Good boy. This you have got this. Delta's universe is delta's system, delta's surrounding. I often do this is negative. Hence, impossible. These gentlemen. So you are satisfied now. Yes, sir. So this is the meaning statement. What is the meaning? 100% efficiency impossible. Reversible cycle, though 100% efficiency impossible. That is the whole meaning of this statement, 3-line statement. And then how to establish this or how to verify this with the help of entropy? You see. Okay. And also through this, I showed you here. What I showed here, QH minus QL also, it gives you 100%. So I said that it is 100%. Meaning is 100%, and which is impossible. Thank you very much. With these words, we have completed today's lesson, and so we'll see you next day. Thank you very much.